Hello everyone. This is polynomials chapter from 10th textbook maths. That is third chapter polynomials. From today onwards I'll start to explain the different terms and exercise examples and all. Do this and try this in this chapter. So first of all we have to know about the exact meaning of this polynomial. What is the meaning of this polynomial? Poly means many. Two or more than. An expression, polynomial's meaning is, polynomial is an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variables. Means, here look after here, poly means many. So the expression is an expression. Polynomial, it's nothing but an expression of more than two algebraic terms. What do you mean by this algebraic terms? I'll explain here. So what of more than two algebraic terms, especially the sum of several terms. Sum means addition. The sum of several terms that contain different powers of the same variable. What do you mean by this variable? Okay, I'll explain in the next point. What do you mean by this variable, right? Variable means a symbol which takes on various numerical values is called variable. Means, for an algebraic expression, for example, if you write any algebraic expression, that is ax plus b, here a is, these all are constants, a, b, these all are constant. By the constants, when you write this x, y, z just like that, this type of these terms, the symbols which is used as a variable, the symbols which we call as variables. A symbol which takes on various numerical values. These are numerical values, and the symbol which takes on the various numerical values is called variable. Okay, just like I am giving example on this, that is 3x square plus 4. Here 3 and 4 are the numericals and x is a variable. I am giving one more example for you, that is 5x cube plus 3x square plus 2x plus 1. Look at here, 5, 3, 2, 1, these all are numerical values. The symbol which takes on various, the symbol here, look at here, x cube, x square, x to the power of 1, just like that. When you are using these symbols, look at here, in the definition of this polynomial we have a same variable, different powers of the same variable. Different powers means, here we have the power 3, and here we have power 2, and here we have power 1, and when you assume that here x to the power of 0 we can write. Why? Because anything to the power of 0 which becomes 1. So assume that, just imagine that x to the power of 0 is also equal to 1. Anything to the power of 0 is equal to 1. Hence here there is a power 0, x to the power of 0. So they are different powers. Look at here, they are different powers with the same variable. Variables are same, x cube, x square, x, right? These variables are same. So for this kind of equations, for this kind of algebraic expressions, we called as polynomials. And look at here, by using of in the symbols which takes on various numerical values, the symbols which we used, that is x, whatever it was, x, y, z, as you like, you just use any variable, but you just use only one variable. The same variable you have to use and the different powers you can use, right? That kind of expressions we call as polynomials. In this algebraic expressions, x, we can use anything, no? I'll give one more example for you, that is in the same expression you can write by using of this L cube, 3L square, 2L plus 1, right? The variable you may change, right? So that is the variable. So the next one is constant. What do you mean by this constant? Constant means a symbol having a fixed numerical value is called constant. So already I said, no, in this given example the 5 is a constant, 3 is also a constant numerical value. Okay, a symbol having a fixed numerical value is called constant. Fixed numerical value is called constant. For example, the constant number we can write it as 2, 5, minus 10, just like that. These all are the constant values. These all are the constant values, right? Next, what is algebraic expression? Look at here. Polynomial is an expression of more than 2 algebraic terms. No, what is algebraic expression? Algebraic expression. So algebraic expression means the combination of constants and variables. Constants and variables with, maybe we can use the plus, minus, into, division is called an algebraic expression. Algebraic expression. For example, some examples I am giving here for the algebraic expression. Already I said to you, this one is algebraic expression, this one is another algebraic expression, this is another algebraic expression. We can write by using of this numericals and variables, numerical and variable, constant, variable, constant, variable. We can write this expression by using of this all, right? A plus, some different, that is minus, into, division, whatever the symbol you can use in the algebraic expression as you wish, right? Here the first example is 12x square minus 7x cube plus 3, right? It is one numerical, that is algebraic expression. So the second example is 7 x to the power of 5 minus 3x square minus 2 is also an example for the algebraic expression. Okay, so what is the exact definition for this polynomial? Exact definition for the polynomial. So here an algebraic expression in which the variables involved have only non-negative integral powers is called polynomial. Look at here, from above all the expressions, is there any negative powers are there? Is there any negative powers? No. If we express this negative powers, if x to the power of minus 2, when we use this negative powers, it's not a polynomial. Only the positive powers has to be right for the variables. Look at here, the exact definition for the polynomial. An algebraic expression. It's an algebraic expression. It is one of the algebraic expression in which the variables involved. Variables means x, y, z, l, m, n. Whatever you want, you can write. Right? The variables involved have only non-negative integral powers. It should not have any negative powers. That kind of algebraic expressions we called as polynomial. Polynomials are constructed by using of these variables and constants. Polynomials are constructed using constants and variables. Polynomials are constructed using constant and variables. Polynomials are constructed by using of constants means the numbers, numerical values, and the variables means already we saw that variables in the before page, that is x, y, z, l, m, n, a, b, c, whatever you want you can use, right? By using of these two we can construct this polynomials. One more important point you have to remind that is coefficients operate on variables which can be raised to various powers of non-negative integers exponents. So for that I will show some examples for you which are not polynomials. First of all, we should write this point in your notes, that is coefficients operate on variables which can be raised to various powers of non-negative integer exponents. Means example, so if the algebraic expression is just like this. The first example I am giving here, 1 by x square. How can we write this? For example, in exponents and powers in your 8th standard, one formula is there, 1 by a to the power of n, that is equal to a to the power of minus n, right? What the power you get here? Negative. If we convert this just like this formula, so x to the power of minus 2, is it right? What kind of power for this variable? Here there is a negative power. If there is a negative power for the variable, it's not a polynomial. So hence it's not a polynomial. Just remind, the negative powers should not be taken for polynomials. The coefficient operate on variables which can be raised to various powers of non-negative integer exponents. Right? So second example, 1 by square root of 2x. How can we write this? 1 by 2x to the power of 1 by 2. square root, it changes into power of 1 by 2. If you write this expression just like this, so 2x to the power of minus 1 by 2. Is it a polynomial? No, it's not a polynomial. Why? Because we have negative power. We have negative power. Just like this, these are the examples for the negative powers. So this kind of expressions we can't call it as a polynomial. We can't call it as a polynomial, right? So first of all, you have to find out the degree of the polynomial for the expressions. Degree of the polynomial. What do you mean by this degree of the polynomial? Degree means power. Degree means power. So what is degree of the polynomial? Right? Degree of the polynomial. The exponents of the highest degree term in a polynomial is known as its degree. Okay, is known as its degree. For example, look at here. So 2x square minus 5x to the power of 5 plus 7x to the power of 1 minus 6. Which is the highest degree for this algebraic expression? Here the power is 2, here the power is 5, here the power is 1. It's a constant term, but we may imagine that x to the power of 0 is there here. Already I said to you, anything to the power of 0 which becomes 1. 6 ones, 6. So it's a constant. What is the power of this constant then? 0. What is the power of this constant? 0. Why? Because we are imagining that x to the power of 0 is there here. Okay. So what is the highest power of this algebraic expression? 5. So here for the above equation, the degree is 5 is the degree of the polynomial. Degree of the polynomial. It is one example, right? So I am giving here one more example. Polynomial. It is polynomial. We can express this polynomial as p of x. P of x means in the variable x, we are expressing the algebraic expression by using of this variable x. So p of x means polynomial in the variables of x. Okay, that is equal to p of x is equal to 5x to the power of 7 plus 10x square minus 5x. It is one algebraic expression. What is the highest degree? 7. What is the highest degree means? Degree, highest power means 7. So x to the power of 7, x to the power of 2, x to the power of 1. What is the highest power? 7. So 7 is the degree of the polynomial. Okay guys. So the next one is zero polynomial. What do you mean by this zero polynomial? So we are clear about this degree of the polynomial, right? In a given expression, what is the highest degree, highest power? We call it as a degree of the polynomial. What is zero polynomial? Zero polynomial means a polynomial of degree 0 is called zero polynomial. Is called zero polynomial. For example, for which algebraic expressions we have power 0? For a constant terms. For a constant p of x, if p of x is equal to 8, just assume that 8 into x to the power of 0. Anything to the power of 0 is equal to 8 into 1. That is equal to 8. For a constant terms, we have degree 0. For a constant terms, we have degree 0. Just it is the imagination of you, right? It was the imagination of you. You just assume that for a constant terms there is x to the power of 0. For a constant terms we call it as the degree is 0. Okay, one more example, that is minus 10. Yes, if we can imagine that x to the power of 0 is there here. So what is the degree of this polynomial? 0. For that constant terms we called as 0 polynomial. A polynomial of degree 0 is called 0 polynomial. Okay. So next one is linear polynomial. What do you mean by this linear polynomial? So linear polynomial means, so the polynomial of the degree 1, a polynomial of the degree 1 is known as linear polynomial. Linear polynomial. For example, p of x is equal to, p of x means polynomial in the variables of x, that is equal to 2x plus 5. Okay, 2x plus 5 means here there is no power. If there is no power, that is equal to 1. 2x to the power of 1. What is the degree of the constant term? Just only I said no. For the constant terms you have to imagine that x to the power of 0 is there. So what is the highest degree of these two variables? 1 is the highest degree. Here 1 is the highest degree, that we for that kind of equations we call as linear polynomials. If the polynomial have highest degree 1, if a polynomial of the degree 1 is called linear polynomials, right? For the linear polynomials, the general form of the linear polynomial is ax plus b, is the general form for the linear polynomial. The 0 of the polynomial we can equate that ax plus b is equal to 0. Here a should not be equal to 0. If a is equal to 0, then it becomes a constant term. For the constant term the degree is 0. But we know that is a linear polynomial. The highest degree is 1. Hence ax plus b is equal to 0 is the general form for the linear equation, but a should not be equal to 0. A should not be equal to 0. Okay. So we can express this linear polynomial into two ways, that is binomial as well as monomial. Okay, I am giving one example here. So linear polynomial we can express in two different ways, right? So example 2x is a linear polynomial. But we have only one term, that is 2x. This kind of term, only one term we have, right? So this kind of linear polynomial, but it is a linear polynomial. Why? Because the power of this x is 1. The power of this x is 1. But there is no constant, no problem for that. So only 2x, this linear polynomial have only one term with the degree 1. But for this kind of linear equations, linear polynomials, we call as a monomials. Monomials means only one term. So we can express this linear polynomials into two terms also, right? 2x plus 7. How many terms we have? 2. Is a linear polynomial. Why it is a linear polynomial? Why? Because the highest degree is 1 polynomial. But we have 2 terms. So for this kind of polynomials we call as binomials. Bi means 2. Mono means 1. Mono means only single term, but it is a linear. Single term, but it is linear. For this kind of polynomials we call as monomials. So not only this linear polynomials, quadratic polynomials, cubic polynomials, also we can express this in a monomials, binomials, trinomials, multinomials, right? So this kind for linear polynomials we can express this linear polynomials into 2 different ways, that is monomial and binomials. Bi means 2 terms, 2 terms we have, that we call as binomials. Okay, next after this we have quadratic polynomials. A polynomial of degree 2 is called quadratic polynomial. A polynomial of degree 2. Here what is linear polynomial? The degree is 1. The highest power is 1. For that kind of polynomials we call as linear polynomial. If the polynomial of degree 2 is known as quadratic polynomials. Okay, so for example, p of x is equal to 7x square minus 6x plus 2. What is the highest power of this? Here the variable is x. It is a polynomial. It is an algebraic expression which has the variable as x. So p of x, so 7x to the power of 2, 6x to the power of 1. So 2x to the power of 0, just we are imagining, right? So what is the highest degree? 2. So if the degree of the polynomial is 2, that kind of equations we called as quadratic polynomials. So quadratic polynomials. What is the general form? General form of quadratic equations or quadratic polynomials is ax square plus bx plus c is equal to 0. Okay, and here also you have to write should not be equal to 0. Why? Because if it becomes 0, 0 into x square, 0. Then the equation which becomes linear equation, right? If a which becomes 0, if a is equal to 0, so 0 into x square, 0. So hence the expression which becomes bx plus c, bx plus c. Then the equation is linear polynomial. Hence a should not be equal to 0. Hence a should not be equal to 0. In this quadratic equations we can express this as monomials, binomials and trinomials. Just I am giving the examples for you. That is if it is 7x square, is it a quadratic polynomial? Yes, it is a quadratic polynomial, but we have only one term. Right? So in this kind of quadratic polynomials we called as monomials. So is a quadratic polynomial, but we have only one term, hence it is monomials. So for example, if we have 7x square minus 6x, Is it is a quadratic polynomial? Yes, it is a quadratic polynomial. Why? Because the power is 2, right? Is a quadratic polynomial. But we have two terms, hence it is binomial. Okay, third example. So 7x square minus 6x plus 2. Is it is a quadratic polynomial? Yes, it is a quadratic polynomial. But we have three terms, hence it is trinomial. Okay, so we can express this quadratic polynomial as monomials, binomials and trinomials. Okay, next we have cubic polynomials. What do you mean by this cubic polynomial? A polynomial of degree is known as cubic polynomials. For example, 3x cube minus 7x square plus 2x minus 10. So what is the highest degree of these all? X cube, x square, x to the power of 0. The highest degree is 3. Hence it is a cubic polynomial. Okay, the general form of cubic polynomial is ax square plus ax cube plus bx square plus cx plus d is equal to 0. But here also a should not be equal to 0. If a becomes 0, if a is equal to 0, then it becomes quadratic equation. Okay, hence a should not be equal to 0. So after this cubic polynomial, we can write any kind of polynomials. Nth degree polynomials I'll show here. So nth degree polynomial. So nth degree polynomial, p of x is equal to, the nth degree polynomial, we have a polynomial in one variable, that is x of degree n, right? Cubic polynomial means the degree is 3, quadratic polynomial means the degree is 2, linear polynomial means the degree is 1, zero polynomial means the degree is 0, and the degree polynomial means the degree is n, right? So a polynomial in one variable x of the degree n, is an expression of the form p of x is equal to an, x to the power of n. Okay, an is a constant, just like this, x to the power of 3 plus bx square plus cx, a, b, c, d we are using in the general forms, just like that, an x to the power of n plus n minus 1 x to the power of n minus 1 plus n minus 2 x to the power of n minus 2, and so on, a1x plus a0. It's a constant, where in the above equation it is nth degree polynomial. Means highest degree polynomials. How can we express these terms? So cubic polynomials we can express ax cube plus bx square plus cx plus d, just like that. Nth degree polynomial we are expressing just like this equation, where a0, a1, a2 and so on an are constants here. Yes, are constant terms. Here an should not be equal to 0. Why? Because here the power n should be here. Nth degree polynomial means the highest power should be n. Hence an should not be equal to 0. Should not be equal to 0. Yes. So by this equation you can write using of this in the place of this a0, a1, a2 and an, in the place of this you can use any constant terms, and by using of this variables also you can use any variable, right? In the place of this x you can write y, you can write z, but you just use only one variable throughout the equation. Throughout the equation only one variable you should use. If we are using this polynomial, x is a variable, we have to use all the x terms. If you want this L as the variable for this equation, you just use that L throughout the expression. Okay, and constant should be your wish. Constant should be a0, a1, a2 and up to an. You can use any term, b0, b1, b2, z0, z1, z2, just like that. You can use any variable, any constant. Okay, that is nth degree of the polynomial. Value of the polynomials means if p of x is a polynomial in x and alpha is a real number, then value obtained by replacing x as alpha. Okay, by replacing this x as alpha in p of x is called the value of a polynomial. I'll explain this by using of this example. So you just take example, p of x is equal to 2x square minus 5x plus 10. It is a polynomial. If x is equal to any constant value, here alpha is a real number, then the value obtained by replacing x as alpha means any real number. If I want x is equal to 2, if x is equal to 2, you just substitute this x is equal to 2 in the polynomial, in the given polynomial. That implies p of 2 is equal to, you understand this? Now you just look after this definition. Value of the polynomial means p of x is a polynomial. Here p of x is a polynomial in x and alpha is a real number. Alpha means any value. Then the value obtained by replacing x as alpha, x as 2. You just replace this x as 2. Okay, then you will get the p of x value. Then you will get the polynomial value. So p of 2, 2 of 2 square minus 5 of 2 plus 10. So 2 into 2 square means 4 minus 5 2's 10 plus 10. Plus 10 minus 10 cancel. That is equal to 4 2's 8. It is the value of the given polynomial. Just like this, you have to find out the value of a polynomial. I think you understand well. So you just understand this alpha also. Alpha is a real number. Whatever the real number, you just take here. So that real number you should substitute in the given polynomial. Then you will get the final value of the polynomial. Okay, that is value of the polynomial. The next topic is 0 of a polynomial. 0 of a polynomial. What is 0 of a polynomial? A real number k is said to be 0. a real number k is said to be 0 of a polynomial p of x at p of k is equal to 0. Okay, that implies example. First example I am giving here. The 0 of the polynomial plus 3 is minus 3 by 2. How can we get this minus 3 by 2? Okay, 0 of the polynomial means you just equate this polynomial p of x is equal to, that implies 2x plus 3 is equal to 0. You just equate this polynomial to 0. So that implies 2x plus 3, it becomes minus 3, that is equal to x is equal to minus 3 by 2. You just equate this polynomial equal to 0, then you will get the 0 of the polynomial. Okay, 0 polynomial is different. 0 polynomial means, in the first introduction part I will explain to you the 0 polynomial. What is 0 polynomial? The degree is 0. If the degree is 0, for the constant terms the degree is 0, just like this, that is 0 polynomial. 0 of the polynomial, it is 0 of the polynomial. What is 0 of the polynomial? When you equate this polynomial equal to 0, then you will get the 0 of the polynomial. Okay, it is the final answer. It is x. That is 0 of the polynomial. If you substitute this x is equal to minus 3 by 2 in the given equation, you will get 0. Okay, if you substitute this x is equal to minus 3 by 2 in the given polynomial, then you will get 0. That we called as 0 of the polynomial. You just check it once. You just substitute this minus 3 by 2 in the given equation. Okay, I will show in the rough paper. Look at here. So x is equal to minus 3 by 2. No, what is the given polynomial? 2x plus 3. That implies 2 of minus 3 by 2 plus 3. Minus 2 cancel. Minus 3 plus 3. 0. That we called as 0 of the polynomial. I think you understand well. Now you just prepare one table for the different types of polynomials we have. That is, type of a polynomial, you just make one table. Okay, to understand in the better way. Okay, so after that you just make one table for the easy recognition. Okay, so types of a polynomials: general form, number of zeros, degree of the polynomial, 0 of the polynomial, relationship of the zeros of the polynomials, graphical representation. Okay, the first one is linear polynomial. You know well, that is linear polynomial. The general form is ax plus b is equal to 0. Means a and also a should not be equal to 0. Number of zeros. How many number of zeros you will get? The 0 of the polynomial means ax plus b is equal to 0. Ax is equal to minus b. X is equal to minus b by 2. B by a. How many zeros you will get? Only 1. How many x values you will get? Only 1. What is the degree of the polynomial? Degree of the polynomial means highest power, that is also 1. What is the relation between the zeros? What is the relation between the zeros? X is equal to, what is the value? Minus b by a. What is minus b? B means constant. From the equation it is a constant. Minus constant term by a means coefficient of x. right? So it is the relationship between the zeros of a polynomial. It is a relationship between the zeros of a polynomial. X is equal to minus b by a, that is minus constant term by coefficient of x. What is the graphical representation you will get for this linear equations? That is straight line. Straight line. Okay, you will get the straight line for the linear equations when you draw this graph for the linear equations. So I'll show this graphical representations in 3.2 exercise. Okay, I'll show this graphical representations in 3.2 exercises. You will get these all sums in 3.1, 3.2 exercises. Don't worry. Okay, so second one, that is quadratic equation. Quadratic polynomials. So the general form is ax square plus bx plus c is equal to 0, and also a should not be equal to 0. How many zeros of the polynomial you will get? 2 zeros. Why? Because the degree is 2. The degree is 2, you will get 2 values. Just assume that 2 values as alpha and beta. Alpha and beta are the degrees. Okay. The general form 0 of the polynomial, how can you find out? X square minus alpha plus beta is one relation, and x plus alpha beta is another relation. Okay, so the number of zeros you will get as alpha and beta, 2 values you will get. 2 values. X is equal to alpha beta. That 2 values, so number of zeros are 2. Here the degree is 2. The number of zeros also you will get is 2. The 2 values you can assume that alpha and beta. Just we are imagining that values are alpha and beta. X is equal to minus b by a. Just like that, x is equal to alpha, x is equal to beta. You will get 2 answers for this quadratic expressions. So what is the relationships of this alpha and beta? Alpha plus beta is equal to minus b by a is one relationship of the zeros, and one more thing is alpha into beta, that is equal to c by a. C by a. Here alpha plus beta means sum of the zeros. Sum of the zeros. Here it is product of the zeros. Product of the zeros. So minus b and a. B means coefficient of x. Coefficient of x by a means coefficient of x square. So here c means constant term by a means coefficient of x square. Okay, so the graphical representation is parabola shape, means U shape or U shape. U shape. And note, just remind this note, if U shape upwards, U shape upwards, A is greater than 0. If A is greater than 0, then U shape you will get is upwards. If A is less than 0, U shape downwards. The graphical representation you will get is U shape, but in the given equation, look at here, but in the given equation, if A, in the place of A, there is a greater than 0. Greater than 0 means 1, 2, 3, 4 and so on. Okay, if A value is greater than 0, then U shape you will get in the graph is upwards. If in the value of A is you have any negative numbers, that is A is less than 0, then U shape downwards. Okay, U shape downwards. We will check this graphical representation, that is U shape upwards, U shape downwards, is also in the 3.2 exercise. And if you can't understand this alpha and beta in these sums, You will understand in the better way while doing the sums in 3.1 and 3.2. Okay, 3.1 and 3.2. Don't worry. Okay, alpha and beta are the zeros of the given polynomial for the quadratic equations. Okay, you just make the notes in a proper way first, then while doing the exercise sums you will understand in the better way. Third one, that is cubic polynomials. Cubic polynomials. What is the general form? Ax cube plus bx square plus cx plus d is equal to 0. Okay, so a is not equal to 0. A should not be equal to 0. What are the number of zeros? Here we have alpha, beta. So the number of zeros are alpha, beta, gamma. You will get 3 zeros. So number of zeros are 3. Degree is 3. What is the relationship of the zeros of the polynomials then? 3 we have. The first relationship is sum of the zeros. That is alpha plus beta plus gamma. That is equal to minus b by a. What is minus b by a? Here minus b means minus b, and b means coefficient of x square by what is a? Coefficient of x cube. Coefficient of x cube. Okay. So second relationship is sum and product of the zeros. Sum and product of the zeros. Alpha beta, beta gamma plus gamma alpha is equal to c by a. What is c here? Coefficient of x. Coefficient of x by coefficient of a means x cube. Okay, x cube. The third relationship is product of the zeros. Product of the zeros. So alpha, beta, gamma is equal to product alpha into beta into gamma is equal to minus d by a. That is equal to minus d means constant term by a means coefficient of x cube. These three are the relationships of polynomials for the cubic polynomial. For the cubic polynomial, what is the graphical representation? S shape. There is no need of to draw this graphical representation in your 10th class. This is S shape. You will get S shape as a graphical representation for this cubic polynomials. For this cubic polynomials. Okay. So it is a table you have to make in your notes. You just make your notes in a perfect way. The next topic is the last, and the next topic is division algorithm. The division algorithm. One more thing, you just write here in the cubic polynomial, one equation is there here. You just write here, that is x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma is equal to 0. It is a general equation in terms of x values, in terms of the zeros of the polynomials, in terms of the relationships of the zeros of the polynomials. Okay, just like this, just like this, x square minus alpha plus beta into x plus alpha beta, right? For the quadratic equation, for the cubic equation, it is a general equation in the zeros, in terms of zeros. What is the division algorithm? The last term, the last topic for this division algorithm, that is, what is division algorithm in your childhood? For any division, if we have that is a dividend is equal to divisor into quotient plus remainder. It is a division algorithm from our childhood, right? The definition I am giving here: if, just remind this one, if p of x and g of x are any two polynomials with g of x is not equal to 0, then we can find polynomial q of x and r of x such that the division algorithm, it makes into p of x is equal to g of x into q of x plus r of x. Okay, it is the division algorithm for the given equations. P of x is one polynomial, g of x is one polynomial. If normal numbers, for the normal numbers we call it as a dividend, divisor, quotient and remainder. Just like that, we are doing this division for the polynomials. For the polynomials we call it as a p of x as a dividend, g of x as a divisor, and the quotient what we get from the polynomials. So what we get from the two polynomials as a quotient, that is we call it as a q of x and remainder as r of x. Okay, by using of this knowledge we can solve this all the sums in the chapter. Okay, thank you.